Hello all, welcome to Leetcode Daily Challenge. Today's problem is valid arrangement of pairs. So in this problem, we are given 0 index 2D integer array pairs where pair I is equal to start I and end I. And an arrangement of pairs is valid if for every index I where I is greater than equal to I and less than pairs dot length, we have end of I minus 1 equal to start of I. So whatever the end value we have in the previous pair, then the starting of the current pair should be that value. So end of I minus 1 should be equal to start of I, that is represented by. And we have to return any valid arrangement of pairs, and the input which is given to us will be such that there will be existing a valid arrangement of pairs. Okay, let's quickly see how these examples look like. So 5 1 4 5 11 9 9 4. So if you see that 11 9, then 9 4 4 5 5, and they're following that the ending of the first pair is the start of the another pair. Similarly, ending of this pair is start of the immediate next pair. So this is what the question expects from us. In this problem we have 1 3 3 2 2 1. So in this problem, if you see, if you arrange it in any order, it will always be following that order: 3 2 2 1 1 3, because it is a cyclic. Yeah, cyclic we are forming. So placing it in any order will do the job. In this problem we have 1 2 1 3 2 1. So the possible arrangement is 1 2, then 2 1 again, and then 1 3. So this is what we have to do in this problem. If you look at the constraints are 10 to the power 5, that is the length of the pair that will be given to us. Every pair will have two elements, start and end, and the value can range from 10 to the power 9. Okay, now let's quickly see how the examples will look like if we try to plot them node wise in directed graph. So we had 5 pointing to 1, 4 pointing to 5, 9 pointing to 4, 11 pointing to 9. So this is basically the how it is pointed, because I'm taking two nodes. Let's say we are given 11 comma 9. So 11 pointing to 9, 9 comma 4 is given. So 9 pointing to 4, 4 comma 5, 5, 4 pointing to 5, 5 comma 1, 5 pointing to 1. So this is how I made it. I have also noted down the incoming and outgoing edges. So 11 has 0 incoming edges and 1 outgoing edge. Similarly, 9 has one incoming edge and one outgoing edge. 4 has one incoming, one outgoing. 5, one incoming, one outgoing, and 1 has only one incoming edge. So I have noted it down. We'll be using it. So that is why I have mentioned it. Another is the second example. It was a cyclic directed graph, 1 pointing to 3, 3 pointing to 2, 2 pointing to 1. Everyone has one incoming and one outgoing edge. Another problem was 1 pointing to 2, 2 pointing back to 1 again, 1 pointing to 3. So 3 has one incoming edge, 0 outgoing edge. 2 has one incoming, one outgoing. 1 has two outgoing and one incoming edge. So the order is wrong here. It has one incoming and yeah, two outgoing. Yes. So this was the example case. I will prefer this example for better explanation. So what if in 4 we have another pairs are 4 5 5 17 and 7 4. So this is how the graph will look like. Now 4 will be pointing to 15, 15 will be pointing to 17, 17 pointing back to 4 again. And now I have, this is the updated incoming and outgoing edges from taken from the first part. Now 4 is having one incoming, second incoming, two outgoing, one outgoing, two outgoing. Rest will remain the same. Apart from that, 15 will be added, one incoming, one outgoing, 17, one incoming, one outgoing. So this is how the incoming and outgoing edges will look like. Next, the idea is that we have to find a traversal technique such that in that traversal technique, in the order in which we get the traversal, we get the pairwise, we can pick it up, and that will be our answer. What I want to say by that, let's quickly go back to the first example. We have this path 11 9 4 5 1. So if we take the path, the first two elements of the path pairwise, 9 4 4 5 and 5 1, so that was our answer, right? In this problem, if we take the traversal, 1 3 and 2 will be our the path. Eulerian path is basically where I wanted to land it up. This is a good article on GFG, this Eulerian circuit directed graph and Eulerian path they are given. So what is Eulerian path? Is a trail in an infinite graph that visit every edge exactly once, allowing for revisiting vertices. An Eulerian circuit is an Eulerian trail that starts and ends and the same vertex. So about Eulerian circuit, this is the Eulerian circuit, and this is the Eulerian graph in which, Eulerian path we will be what we basically will finding out by the traversal technique. Okay, so this is the circuit, and this is the normal graph in which we'll find the path, and here we will get the circuit since it is directed cycling. So you can read it out there more about it, but yeah, let's continue with the discussion. So that was the stuff that we wanted to talk about. So another thing you wanted to note it down here is that 11 does not have any incoming edges. So I want that the going edges, the outward going edges are more in number than the incoming number of edges. If you see, it has only incoming edge, no outgoing edge. Rest have one incoming, one outgoing. 11 has one outgoing edge. So that is what I wanted. So another here, everyone has the same incoming and outgoing edge. Here, everyone does not have the same. One has two outgoing and one incoming. Two has one outgoing, one incoming. Three has one incoming. So I want a node where it has more number of outgoing edges. I will start my DFS traverser from there itself. So quickly jump to code. So here what I'm doing is I'm basically maintaining an unordered map for in degree and out degree. In degree and out degree basically is the incoming edge and outgoing edges. I will maintain an unordered map. This is can be basically imagined as the adjacency graph. Since the numbers can range to 10 to the power 9, that is why we have to use map. Otherwise, you can go with the list with vector of vector with defined size. We will be using vector of answer where the path will be stored. And this is the DFS traverser that I'll go to particular I. I check that out degree of I that will come back to later. Initially, these were the sticks that we have to initialize. Next, I'm taking one set, Y set. I'll talk about it. Now, what I'll do is I will iterate over the pairs. I will go to every pair. I'll see that the second element's in degree should be incremented by 1 and out degree of 1 should be incremented by 1. Why so? If we have 11,9, this will be pointed like this. So 9's incoming will be increased by 1 and 11's outgoing will increment by 1. So that is why we have incremented that here. And in G of I of 0, because this is how the graph will look like since it's directed, this will have a pointer pointing to 9. So that is why G of I of 0 push back I of 1. And in the set I will be inserting the both the elements. Why so? Because I will then iterate back in that set because there may be duplicate elements. Uh, uh, let's say for this example we have 1 2 2 1, so there was two times 1 that were appearing. I don't want that. I wanted to iterate it only once. That is why I'm maintaining a set and inserting there. I will iterate over the set. I will see that out degree is equal to in degree plus 1. Okay, out degree should be 1 more than the in degree. That is why I told you that I want you to start it at some particular point that has outgoing edges greater than uh, incoming edges. So that is why I want to point it out to that particular node. If I get that, I'll update my start with that. I can simply break it out after it by to continue. If I got there that particular node, then I have the start. I will initialize with the very first element that if there is no such condition satisfied, simply take the very first because that might be Eulerian circuit. So yeah, in that case, just take the very first element and start the DFS traverser technique. Okay. So in DFS traverser technique, what we have to do, this is I is our node. We'll check what is the out degree of the node. It should be greater than 0. If it is, we'll continue. We will reduce the out degree by 1. But we'll also take the J. What J means that in that the adjacency list of I, take the element that will be out degree minus 1 because we are storing it in a vector of in a vector what is mapped to a particular node. So that will be our vector. What does this mean? That in this example 4 will have 5 and 15 in its vector. So based on whatever the size we have, first 8 will go to 5 and then another iteration will go to 15. So that is what we want to achieve here, and continue the DFS traversal for J. And once the traversal for J is continued, in answer you just push back I. Okay, so how this will look like? If you start your traversal from 11, it will go to 9 4 5 and 1 will be pushed back because we don't have any further outgoing edges from 1. 1 will be pushed back, it will return to 5, 5 will be pushed back to answer, then 4, then 9 and then 11. So that is why the pair I will get here will be 1 5 4 9 11. Okay, this is what it will, the answer will finally store after the traversal is being done. Okay, before that we'll quickly check that it will start from 11, it will go to 9, it will go to 4. Now it has two paths. It might go to 5 1, it might go to 15 17 and come back to 4. So that is not a deal. Let's simply focus on the DFS traversal. It went to 4, then 4 it went to 15, 15 to 17. It is running back to 4, and it does not have any outgoing edges now. So when it will be returned it out, it will go to we are at 4 again. Now in 4 we'll go to 5 and 1. I'll store back 1, I'll store back 5, I'll store back 4. Then this will be returned in the recursion of 17 will be stored, 15 will be stored, 4 will be stored, 9 and 11 will be stored. So this is how it will look like. 1 5 4 17 15 4 9 11, and then this is how basically whatever answer will be stored in it. Okay, yeah, after reversal I will basically reverse my answer whatever the values I have. Why so? Because I want to have a pairwise numbers. So if I started from yeah, if I started from 1 5, my pair is 5 comma 1, so that is why I reverse it, so for better understanding. So I, instead of 1 5 4 9 11, I will start with 11 9 4 5 1. Similarly here also, instead of starting it this is actually, this is what the final my answer would look like, and after reversal it would become 9 11 9 4 15 15 17. So yeah, there's the placement is different. This is what originally my answer will look like, and after the reverse it will look like this. And now what I'll do is basically I'll start from 1 and take answer -1 and I in my return vector of vector, and I will finally return that. That will be my answer. So after return it will be 11 9 9 4 4 15 15 17, then 17 to 4, and then 4 to 5 5 to 1. So if you see that it is following this order, that from this node pointing to another node, this is basically the pair that we are getting. So this is only that we have to do in this problem. This was a pretty good problem, I found it, because it taught me how what taught not basically taught it. We must have studied in our college, but yeah, Eulerian path, Eulerian circuit. It was good revision going out there and how it is being implemented over there. So if even if you don't know that stuff, you can simply using DFS and how you are storing those, you can simply find it out, even if you don't have the knowledge about Eulerian circuit and all. But yeah, it was mentioned in some of the comments, so I see that and I tried to understand what was that. So yeah, that was all for this problem. If you have any query, do comment it out. I'd love to resolve them. And if you like the button, hit the like button and do subscribe for more daily content. Thank you.